Manifold design class. Reviewing the specifications for project number 1, we're using a DC prime mover electric motor. We're going to power up gravity down with the cylinder. The cylinder needs to be able to stop mid-stroke on the up or down direction of travel. DC directional control valve, so we're going to use a solenoid on that. System relief valve needs to be integrated into the circuit. Our flow requirements for this circuit are 4 gallons a minute and pressures 1,650 psi. We reviewed the different schematics and we came back and realized that by doing a simple non-traditional circuit we can save a lot of money. So for the manifold, the electric motor, the prime mover, the cylinders, they're not included in the manifold. All we have in the manifold is the check valve, the directional control valve, and the relief valve, and pricing that out came to $92 doing this circuit. Let's take time to review what the students came up with. Here's one example. Oil can come in here. We're going to take the simple flow path first. We come in the inlet over to the relief valve. If the relief valve goes and opens up, it's going to relieve and go back to the tank. This would all be at one level inside the manifold, because if we come down here to the check valve, we're going to have to go from level 1 to level 2 on the check valve to go out to the cylinder to do the work. To be able to make this manifold work, we would need to go in and cross drill and connect this flow path on the inlet side to a different level going to the solenoid valve, and once we operate the solenoid valve we'd be able to come out, which we would also then need to put a cross drill in here to connect this cartridge valve to the inlet level and to the tank level. So a couple different ways that we could look at that. If we look at the next circuit, excuse me, the next circuit, we're going to have an inlet here. Come in, here's the relief valve. If we relieve, we go from the system to the tank level. This is at a lower level, and we would be able to come out here to our tank here to relieve. If we come in, we go through the check valve, we go from level 1 to level 2, and that's going to bring us up a level inside of or that'll keep us at the same level inside this manifold, and then we would go out to the cylinder, to the system, and then we'd also be on the directional control valve, which would be normally closed. When the directional control valve is operated and opened, it would allow the oil to flow down through from level 1 to level 2 on the solenoid operated valve and go out through the tank. Works just fine. We might have to do a couple cross drills here to connect those pathways, but easily done. One of the cross drills we would need to drill down on these cartridge valves a little bit or move those down. Next. Whoops. I keep going a little bit too fast on that mouse. So then our next one is, if we come in on this manifold, we come in the inlet, go from level 1 to level 2 on our check valve, and we move out to the cylinder. And then to connect our cylinder flow path that's been cross-drilled over to the directional control valve, so that if we want the cylinder to come down, we energize the directional control valve, we flow from level 2 to level 1, and we go out the outlet port. If we're going to go to the tank port, we're going to come in, go over to our tank connection, or to our relief valve. On the nose of the relief valve, if the pressure gets too high, we'll relieve from level 1 to level 2 and go out the outlet. And notice that their cross drill's been made here to make this connection. So good design, no problem with it. If we go to the next one on C, just by taking this directional control valve and taking our relief valve and moving our relief valve around the corner so that it's in line with our check valve. Take it, move it around the corner. That would make it a little bit easier. So if we go to this option, we line the relief valve up with that. Now there's no cross drills in this. We come in, we can drill straight through here to connect our check valve and relief valve to the supply. The supply comes in, goes from level 1 to level 2, out to the cylinder. We drill in for this one, and we can pick up this connection right here. So if we want to lower the cylinder down, we go from level 1 to level 2 on our directional control valve and flow out and around this cartridge here. So we can flow around those different levels. So we'd flow out here to the tank. If we're coming in, pressure's too high, we'd relieve from level 1 to level 2, go out to the tank port. Nice clean design. This one is another design. We come in very similar to that last one. We come in and we go through the check valve out to the cylinder. If we want to let it down, we would go ahead and activate this directional control valve to let it come out. In order to make this work, we'd actually need to drill and plug going across this direction to create that flow path in there. And then we'd also need to drill and plug this direction here, but absolutely works. So we'd go in through the check valve out to the cylinder. When we want to come down, we'd go level 1 to level 2 through the directional control valve to the tank port. On the relief valve, if the pressure gets too high, we go 1 to 2 and we're out. So another excellent design. So this one here is another great design. This one here, the design on this one, look at this, all the cartridge valves are on one surface. We flow in, go through the check valve, have a flow path here to go out to the cylinder. To connect the directional control valve, this would actually be at a different level, a different flow path level inside there. By putting that cartridge valve on the edge, we would have to drill a hole to connect those pathways together. So we'd make those pathways and we'd be able to relieve from level 2 to level 1, go back, and on our relief valve, when we flow in, we would go and connect up to our relief valve. Through this connection here, we'd flow in, go in at level 2, relieve to level 1, and flow out. So another good design. Option on E, similar to the other ones, right? We would go and flow in, go to either the relief valve, the check valve, go out to the cylinder. If we operate the solenoid operated valve, we can flow oil back to the tank. So we're starting to get into where we're seeing some common design threads on these manifolds. Again, here's another excellent design. Come in, go up to the relief valve, go to the check valve, go out to the cylinder. A few cross drills would need to be done to make this happen, and probably take this out right in this area. We just move that a little bit and line those up. So good design. We go to the next one, and here is another design. We come in and we go through the check valve out to the cylinder to the relief valve. We'd move our relief valve out so that this tank passageway would line up with this one. Otherwise, we'd have two tank passageways. So all of our valves actually are 2 levels. This one here probably got carried away with just 1 additional level we didn't need. And then we come up with the design H. So we'd come in, go in level 2 of the check valve, from the check valve out to the cylinder. If we want to bring the cylinder down, we just operate the directional control valve, allow oil to go from level 2 to level 1 out to the tank, or if we come in, we can relieve from level 1 to level 2. So excellent designs. You guys, I have to say this, out of all the years I've taught and gone over these different manifolds and the first project review, I've had many of them that don't work. Every single person's manifold that was submitted to me, they all work. There were small things that I pointed out to people to make their manifolds better and simpler designs, but excellent designs overall. Nice work, you guys. All right, we need to get on with our assignment. On the assignment, here's what it looks like. There's going to be a write-up here telling us pretty much what we already know. With the exception here, there's new information saying that this assignment is due April 27th. I will send this out as another email. And then it gives us the manifold parameters that we've been covering, but it also gives us dimensional information to say our block can be as big as 7 by 7 by 7. If it's much bigger than that, the manufacturer is going to have concerns. This is going to an original equipment manufacturer. And the other thing that we need to make sure is that we have these design principles in mind. Make sure that we drill and tap holes for mounting the manifold. And then we need to show all of our flow paths going through, and then all the documentation. All the documentation's listed out down below here. This document will be emailed to you, And I will also be sending out a sample project so that you can see how to assemble and what drawings need to be in there, what those look like with some additional help.